Okay, I'm going to show you two ways to do regression using Excel. One, as you'll see, far easier than the other. Alrighty, here is Excel. Now, if you have Excel on your computer, on Mac or on Windows, you're able to do this. You're able to have the tools installed, the Excel add-ins, and the Excel add-in particular we want here is the Analysis Tool Pack, which provides data analysis for statistical and engineering analysis. So you went to, at some point, Tools, and you clicked Excel add-ins, and you picked that. Now, we're going to go to Data Analysis and pick Regression. Now, little thing to know, so I'm going to predict from column 2, which is the total column B, my X, the total number of grants that these faculty members have had in their entire career, and the prior to now, and the number of grants they have at the current institution, which is going to be my Y variable. So I just did, when I entered this, I just did A2 to A199 and B2 to B199. So those were the columns that I wanted. Important thing here, those columns have to not have any missing values. So as you can see here, all of these are valid numeric values. For every one of these in A, there's a corresponding value in B. That's important. I also want a line fit plot. I also want to plot it. And I think that's all I really want at this moment. So I entered the range for A2 to A199, the range for, that's my Y value, B2 to B199 is my X value. I just click OK here. And here's what it gives me. So this is super cool. I can make this plot a little bigger. Probably saw that in in the PowerPoint earlier. And let's step through this. So this is the multiple R. This is just the correlation between those. If I had multiple variables, it would give me a predictor equation using all those multiple variables. In this case, I just have one. The R squared is exactly that, the R value squared. The adjusted R squared, we don't really have to look at that too much right now. It gives me the number of observations, which was 198. It tells me that I have 1 degree of freedom for the regression, 196 for the residuals. The sums of squares for the regression were 139. Sums of squares residual. So this is how much of the sums of squares was explained by the regression. Here is the total sums of squares. And look at this. Let's divide to do equals 139, our regression sum of squares, divided by our total sums of squares. And what does that give us? 20.23715. So amazing. About a fourth of the variance. That's our R square right here, explained variance. About a fourth of the variance is explained by how many grants they had in their career up till now. So other things, how much support they have at this institution, how much energy they have, whether their particular field is something that's fundable right now. So other things explain about 77% of the variance, but this one variable, in this case, the number of grants they had in their career up to now, explains 23.7% of the variance. So that's what that R squared is. And then if we want to look at our intercept, it is 0.533. You see that's about where it is right over here. Our X variable coefficient, so the B value is 0.079, which I rounded to 0.08 earlier. Our T statistic for the intercept, generally we're not that interested in the T statistic for the intercept. We're not generally hypothesizing that the intercept is 0. We are interested in the T statistic for the for our slope here, for our B coefficient. And here you can see it's 7.81. Now, if you remember all the other stuff that we looked at, and generally about 1.96 is significant. So you'd figure, we have 197 people, so that's good bet. 198, it's good bet. So we have a t-value of 7.81, and if you look here, the probability of that is to the -13th. So 0.00000, a whole bunch of zeros in front of that 3. So in that case, this is statistically significant. Again, look at our lower 95% confidence interval for the B coefficient. It's 0.059 to 0.098. You can see that 0 doesn't fall in there anywhere. So both because 0 doesn't fall in the 95% confidence interval, because we have a t-value of 7.8, which the probability of that is very, very low. For all of these reasons, we're going to reject the null hypothesis that there is no relationship. And yeah, all of this we got by just going to Tools, Data Analysis, picking Regression, and giving the values where our y variable was, the values where our v variable was, and then I clicked here because I wanted the line plot to show my regression line. So that's all you need for that. Now there is a way to do this if you don't have the versions of Excel installed on your computer, if you only have the web version, but it's kind of ugly. I'll show it to you anyway. So here I have the same data set, but it is on the web version of Office. And I'm going to put in this equals line est same variables a to A199, comma B2, colon B199, and then true. I want B calculated normally. True, give me some additional regression statistics. Now, this actually gives me a lot of the same numbers, but you would have no idea, right? So let's pull up my original regression that I did on this first number here, this 0.0791095, that is the value for B. But it doesn't tell you that, does it? So this is B. This over here, this 0.53, that might look a little familiar. That is the value for the intercept. So that's A. This is ridiculous, isn't it? This 0.01011 here, this is the standard error for B. And as you might not be too surprised to find, the 0.13 there is the standard error for the intercept. So it gives you all this information, but it's not labeled at all, which to me is kind of ridiculous. This 0.2375, that's the R square, also known as, that's the R square, also known as the explained variance. And the 1.509 is the standard error for the R square. That 61053 there, that is the F value. And F value, as we'll talk about a little bit later, is similar to T, and that it's a statistic that you use to compare the variance between groups that you found to the variance that you would expect to find if the null hypothesis was in fact true. So we'll learn about that a little bit more in another video, but that's the F value. This over here is your residual degrees of freedom. This 139 is the regression sums of squares, and the 446 is residual sums of squares. So if you don't have the Mac or Windows version of Excel, you can type in this equation that equals LINEST for a linear trend and give the location of the values for the Y variable, the location of the values for the X variable, like B2 to B199. Say true. You want to return additional regression statistics. You want B normally calculated. And it will give you these numbers, but it won't tell you what any of them are. So hopefully you have the Mac or Windows version.